Hi guys, I'm recording this video since I didn't attend the study session with you guys. So thank you for understanding my situations, and I think I'm able to renew my America passport because of you guys. And today I'm gonna solve this LRU cache, which is really popular problem. Yeah, I already solved looking at the solution, and I think this is definitely not the medium problem. I personally think it's fucking hard. Yeah, so the problem is implement the least recently used LRU cache. Uh, I don't know how long it will take, but yeah, I'm trying to record myself explaining about this difficult problem while improving my English skills also. So first of all, uh, there's some kind of cache that have a capacity. There's some kind, LRU cache with capacity. So there's a fixed size for it. Second is there's a get function, which means getting the value based on the key value. And if key exists, return the value, and otherwise return -1. Alright, third, put function. Put function is putting the value based on the key value pair gop. So it's similar with the get function. If key already exists, and we should update the value, and otherwise we need to insert for the first time. Alright. The key is considered use if a get or put operation is called on it. Yeah. The instant thinking for me is alright. Okay. Oh wait, and there's also one other important condition. So if the introduction of a new pair causes the cache to exceed, so if the len of list is larger than the capacity, then we need to remove the least recent used key. Yeah. Alright. So I think it would be really great to understand by looking at the examples here. So LRUCACHE null 2. What's 2? Oh, this one is capacity. So example 1. There is a LRU cache with capacity 2, and there is a first function, put function, right? So put this one, 1 and 10. So 1 will be the key and the 10 will be the value. And yeah, I think the most important part of this problem is remember the order of this key value pairs node, because we need to remove the least recently used, and when we want to put, get, or like the problems that considered used if a get or a put operation is called on it, so we need to put those nodes into the right mode value. So yeah, I think that's the key part. And So yeah, and there's a get function, one. So get the value, wait a second, I'm gonna get the value of one. And there's one question here. So since the problem ensure that we need to run those functions in O of 1 average time complexity, so we need to think that how are we going to know instantly what the value is when the key is a 1 in this example. For me, I think the hash map is the best way to look it up. So we're gonna make a hash map with uh, uh, hash map which is larger, which is smaller than the given capacity, which is 2. Alright. Yeah, and then this example, it is also implying that the cache is a bracket, which is hash map, but I think this is not that important also. And I think there is a lot of like part that we need to think of. So for the hash map, like I'm gonna make hash map as a cache. So there's definitely gonna be key value pairs, and I think we don't need to like set the key and value as a number itself, which means we don't need to set the key value as 110 in this case. I think the better way is to set the value in the hash map can be the pointer to the node itself, because we do have a node with key and value pair here. So the reason why we want to make a pointer in the value to the node itself is because we can keep track on the most recent and least recent by pointing to the node, and also, yeah, I think that's the reason. So I'm not sure like how I can express in a like a sentence, but so it's like this. So we do have a key value here, like in this case 1, and the value is going to be the pointer to the node, which is 1 to 10. In this case, we don't need to like update the value. We just know instantly that this value of this hash map key value is going to point the node, and then we know the value if we look at the node. Yeah. I think I'm not really good at explaining in English, so if you have any questions, you can ask to Korean Jeho. And then the one another key part is we need to keep track on least recent use and most recent use, right? Then in this case, I think the one great way is by setting the left pointer, which is the dummy node, to be LRU, and right pointer, which is also the dummy node, to be most recent use. Yeah, I think that's almost it. We can use a double linked list, which is a linked list between the nodes to keep track on the least recently used and most recently used, and then another linked list which is starting from the hash map to the node itself. So we're gonna use double linked list. So yeah, I think that's pretty much it. And then yeah, we can move on to the code. So like I said, so there's no class node at the beginning of this problem. So before we even code about the LRUCACHE, we talked about that we need a node to construct the cache. So I'm gonna make a class node here, constructor function, which we have key and value. So self key is key, self val is all, and also we said we will gonna have a linked list between the nodes, so we will have a pointer constructed here. Oh, and in this case, in the node, I think it will be better to have a previous pointer and a next pointer. The reason why we need both pointer is that if we want to insert or get the insert or remove the value, there is a case we need to put in the middle of the nodes. So in this case, 110, and we would like to have this way. So left pointer, which is the dummy node, and which is LRU, and 220, which is the previous pointer will point to the 110 node, and then the right pointer, which is also the dummy node and most recent nodes, like this. I think we should have both pointer to keep track on the order itself. Alright, so when we construct the node, I think we should have previous pointer to none for the beginning, and next also to the none. Because yeah. Yeah, and I think this is pretty much it. And then in the constructor in the LRUCACHE, so there's gonna definitely have capacity, which is self cap is capacity, and also we talked about that we are gonna have a cache hash map. So self cache is hash map. This is the hash map, which I have a key to the node, right? The value is gonna be the node, which is pointing to the node. And then in this case, we're gonna have also left will be LRU, listening rules, and right will be most recent one. So we're gonna have self dot left and self dot right pointer to be initialized with node 00, node 00, because like we said, this is a dummy node, so key and value doesn't matter. And then at the beginning of this constructor, we need to connect those two nodes, two dummy left and right pointer, left and right nodes, so we can insert the node in the future in the middle of that left and right dummy nodes. So we're gonna just connect those two nodes, doing so. Self left next is going to be self right, and self right previous will be self left. Yeah, by doing this, we successfully connect the left and right dummy nodes with 2 pointer. Alright. And then, yeah, I think we can, sorry, and this is the initial problem. And we can move on to the get function. So this is simply get the value based on the key. Otherwise, return -1, right? So, yeah, like I said, there's gonna be the hash map constructed when we put the nodes here. So first of all, we need to use the if key is in self cache. Then what we're gonna do is return self cache key. In this case, this will get the value which points to node, right? And the node itself has the key and value also. So we are gonna do val to get the number itself inside the nodes. Alrighty. And if there's no key in the hash map, then otherwise we are gonna return -1. Alright. And one thing we have to think about in here is, so the reason why we do have a previous and next pointer is that what do we have to do? We need to update the least recently used and most recently used. So in this case, like in the example, the 1 and 10 node is gonna be between the least and most dummy nodes pointing to each other, and then when we try to put 2 and 20, we need to move the 1 and 10 nodes to the next to the left dummy nodes, and the so wait a second. So I mean, so we set the left, yeah, right, in this case. So at the beginning it was like this. It's not gonna, like, there's gonna be a next pointer also to the this, and then like this. When and in this circumstances, when we want to put the 2 and 20 nodes, what do? The key is considered used if those operations is called on it. So we're gonna put 2 and 20 here, right? To indicate that this one is the most recently used and this is the least recently used within these examples. So in this case, we also have to rearrange the nodes pointer, right? So we need to update the most recent nodes here. Yeah. So in this case, I already showed you guys before, but we need a helper function. I think it will be great to have a two helper function, which is remove and insert. So remove is just remove the node from the list, and insert is insert the node at the right, the rightmost recent, the rightmost position will be the most recently used nodes, right? So we're gonna put the recent one to the most recent use. Yeah, whatever. Fuck it. Yeah. So we're gonna have def remove self with a node parameter, and also this problem is fucked up. insert variable. So in this case, with this helper function, we can do remove the node. Remove the node, and then we can insert that node to the most recently used. So what I'm saying here is, so if key is already in the hash map, right? Let's say in this case, we call get function with key value 1, the node that is that has the key value of 1. In this case, we need to update this node to the most recently used, right? And we can just move this to here, which is the previous node of the right pointer, the most right position, which is the dummy node of the most recently used, right? So we can just do like this. So remove the 110 from here, and then insert to the rightmost one. Insert the node at the right now. Yeah, I think this will do it for now. And then for the put function, it's gonna be also the same. Update the value of the key if key exists. So if key exists in the hash map, what we're gonna do is remove also self cache key, remove the node, and then we need to insert, right? So it's like put function. So self cache key, we're gonna put these key and value node to the hash map by constructing the node with key value. So after constructing the node of key value with the key and value pairs, we need to put those node into the value of the hash map. I already told that we're gonna construct the hash map with the key and the node, which is key is gonna be key, and the node is gonna be the value of the hash map, right? All right. And then since we have a hash map, and we also need to insert into the list, right? So self insert self cache key. So yeah, this insert function always tell us that we're going to put it at the rightmost position, which is the most recently used node. Yeah. And also, there's another thing we need to think here. As you guys, there's a capacity, right? Do we need to also think about capacity? I already told that need to remove the least recently used key, which is why the problem is called the least recently used cache. Yeah, so if the length of the hash map is larger than the capacity of the cache, which is the problem statement, which is here too, then what we need to do here, remove from the list and delete the LRU from the hash map, right? We do have data types here. So we do have a double linked list, and we also need to remove the least recently used list node, and then also we need to delete those corresponding nodes from the hash map, right? All right, so the one way we need the one way we know what is the least recently used is by doing the left dummy nodes next pointer, right? I told you the right of the left pointer is gonna be least recently used node. So this is gonna be LRU for our structure, and we can just do remove and put LRU here because this is node. We can just put this node into here, and also we need to delete, right? We need to delete the hash map value. So we can use the syntax of self cache LRU key. The reason why it looks like this is those node, the hash map and the node has the same key. That's the reason why we do need the key the key cup in this hash map. So it's gonna be the same of the key value of the node. So if we put the key value of the node into the hash map key, like, yeah, 해시맵의 이 키 값을 이 노드랑 똑같기 때문에 이 노드의 키 값을 해시맵에 넣어주면 그 value랑 그게 이제 delete가 된다라는 말을 잘 드리고 싶고. Alright, sorry about that. So first of all, we need to do the helper function right now, and let's think about how the remove function will work. Right? So if there's like, it's like general case, if there's some node, there's node, and there's a next, previous, next, previous, like this. When we want to remove the node from the list, which is, I think in this case, this is going to be the left pointer, which is dummy, which is the least recently used, as we mentioned. Right pointer, dummy, most recently used. And then, yeah, when we want to remove this middle node, what do we do? That's correct. We remove those pointers which pointing to a wrong node, and we just remove all thing and we just make it next node and the previous node to each other, right? This simple thing. So yeah, we're gonna do in here, let's say we're gonna first make a previous pointer. It's going to be node of previous. Next is going to be node of next pointer, obviously. Sorry. Alright, like this. In this case, we already set up the previous and next pointer of the node we want to remove. And what do we do? So the priv next is going to be the next pointer. Do you guys get it? So node next, node next. Oh my gosh, I erased it. Node next is this one, right? This is gonna be next pointer, right? Node next, this one, in this case, right dummy variable. and we're gonna set the previous next. This one. The previous next pointer will point to this NXT, which is the right pointer. So we're making right like this. You guys getting it? It's like jumping up, like skipping the middle one, making the two pointers combine into one pointer. With the same logic, we can do next. Next is gonna be right, the right pointer here. Or sorry, not right pointer, right dummy MRU. Priv is going to be what? The previous, which is the left dummy LRU here. So we successfully construct like this in this case. Alrighty. Okay. And insert is almost similar with like the logic. It's not similar, but so there's a let's say there's a two nodes here, and they're pointing at each other, right? Like this. We're not writing the next pointer of this node because it's gonna be like none, just indicating. We want to put the node in the middle, not the middle, but the right. So in this case, right is going to be here, right? Like, we don't care like, how many nodes in between the left side. So we have to put right here. In this case, what we do is, let's say like this. So in this case, we erase. So this is priv. Oh my gosh, this is in right. This is the rightmost position, right? So this is gonna be right dummy MRU. Yep. Wait a second. So it's gonna be like this, and we made the node between here. And what do? We have to make another pointer pointing to the priv, and also like this. I'm sorry, I think I need a notepad or like some kind of a drawing strategy, but like yeah, the thing is when we want to insert the node, we have to construct the previous pointer and the next pointer for each side of this node, the node two nodes. So there's gonna be next pointer of the previous node is going to point to this new inserted node like this. Alright. So let's go. So we're gonna first declare the previous node and the next pointer. Previous node and the next node to be what? You guys have to think carefully. So previous is going to be self right previous pointer, right? So yeah, so at the beginning we do not have, so let's ignore this one. We only have like this circumstances, right? So the previous node is going to be right, which is MRU, right dummy MRU previous. In this case, what are we going to do? Self right. Okay? So we're setting the previous node and the next node by doing this. Alright. Okay, then let's say, come on, dude. Oh my gosh. So we're gonna insert this node, right? But also this. So let's say previous next is going to be the new node that we have to insert, right? Just the node, and also next. So okay, this one previous next is going to be this arrow, this pointer, and next priv is also going to be node, which is going to be this pointer, right? Right. And now node next, which is obviously this one, is point to the right, which is nxt here. And then node priv, we need to set the both pointer, right? It's going to be the previous node, right? Here, this one. So priv. Okay. I think I also didn't understand this problem, fully understand this problem, but I hope you guys can understand better than me. And again, thank you so much for understanding my circumstances today. I really wanted to join the study session. And shout out to like Jose, like CJ, and Ye Yang, and also Andy. I love you all. Hope to see you soon. Yeah. If you guys have any questions, don't ask me. Ask to Jose. This is pretty much it. Let's run it. Alright, dude. Let's go. Thank you so much, guys.